To summarize Kepler's science, I'm going to do it in a scattergram, a scatter plot. So on the y-axis, I have the radius of the planet in Earth units. So the number 1 corresponds to Earth size, which is marked by the horizontal line. On the x-axis is the orbital period of the planet. And so we see the years are ticking by from the time that that first 51 peg B was discovered up until the present time. Every point on this diagram is an exoplanet discovery made by any team excepting Kepler's. So I'm showing you the sum total of all discoveries as of 2015, excepting Kepler's. And what you notice in this diagram so far is that most of the planets lie above the Neptune line. Indeed, 85% of them lie above the Neptune line, right? We see some patterns there. We've got the blue points that are from the Doppler method. We've got some pink points that are from this transit method, whereby you measure the dimming of light when a planet transits the face of the star. But here it looks like Earth-sized planets, or Earth-like planets in terms of size, are rare, right? But then enter Kepler. Kepler observes this one patch of sky for a full 4 years and searches the data for these dimmings of light. And now I will add to this diagram the Kepler discoveries. Kepler lifted our blinders to the small planet populations in our galaxy, the planets that were there in great numbers that we didn't have the sensitivity to see. But with this new technology, now all of a sudden they became visible. There are over 4,000 yellow points there, many of them stacked on top of each other, so you can't even really get a sense for the sheer volume of discoveries that have been made. But what's really impressive about this diagram is that now 85% of the known planets are smaller than Neptune, which underscores their commonality in the galaxy.